Module 37, Long-Run Economic Growth. Unlike a short-run increase in real GDP caused by an increase in aggregate demand or short-run aggregate supply, we'll see that economic growth pushes the production possibilities curve outwards and shifts the long-run aggregate supply curve to the right. Because economic growth is a long-run concept, we often refer to it as long-run economic growth for clarity. Many economists have argued that long-run economic growth, why it happens and how to achieve it, is the single most important issue in macroeconomics. Before we analyze the sources of long-run economic growth, it is useful to have a sense of just how much the U.S. economy has grown over time and how large the gaps are between wealthy countries like the United States and countries that have yet to achieve a comparable standard of living. In this module, you will learn how we measure long-run economic growth, how real GDP has changed over time, how real GDP varies across countries, the sources of long-run economic growth, and how productivity is driven by physical capital, human capital, and technological progress. The key statistic used to track economic growth is real GDP per capita, real GDP divided by the population size. Why GDP? Because, as we have learned, GDP measures the total value of an economy's production of final goods and services, as well as the income earned in that country in a given year. Think of this as the total size of the economic pie. We use specifically real GDP because we want to separate changes in the quantity of goods and services from the effects of a rising price level. This is the size of the pie after adjusting for inflation. Finally, we use real GDP per capita because we want to isolate the effect of changes in the population. This gives us the size of each person's slice of the pie if it were shared equally. For example, other things equal, an increase in the population lowers the standard of living for the average person. There are now more people to share a given amount of real GDP. An increase in real GDP that only matches an increase in population leaves the average standard of living unchanged. This graph shows real GDP per capita for the U.S., India, and China, measured in $1990 from 1908 to 2008. What are some things we can tell from this graph? One very obvious comparison we can make is the fact that in 2008, China was just reaching the point that the United States had reached in 1908 for GDP per capita, and that India is not yet there, but that both have seen rapid growth in the past 30 years. Now, in spite of the importance of real GDP per capita, most macroeconomists believe that a growth in real GDP per capita should not be a policy goal unto itself, but that it is an indication of how well we are doing in meeting the goal of growth in the economy. This table shows U.S. real GDP per capita across 100 years in 20-year intervals, expressed as a percentage of the 1908 level and as a percentage of the 2008 level. The income of the typical family normally grows more or less in proportion to per capita income. For example, a 1% increase in real GDP per capita corresponds roughly to a 1% increase in the income of the median or typical family, a family at the center of the income distribution. In 2008, the median American household had an income of about $50,000. Since real GDP per capita in 1908 was only 15% of its 2008 level, a typical family in 1908 probably had purchasing power only 15% as large as the purchasing power of the typical family in 2008. That's around $8,000 in today's dollars, representing a standard of living that we would now consider severe poverty. You can get a sense of how poor much of the world remains by looking at this map and which countries are classified according to their 2008 levels of GDP per capita. As you can see, large parts of the world have very low incomes. Generally speaking, the countries of Europe and North America, as well as a few in the Pacific, have high incomes. The rest of the world, containing most of its population, is dominated by countries with GDP less than $5,000 per capita, and often much less. In fact, today more than 50% of the world's people live in countries with a lower standard of living than the United States had a century ago. How did the U.S. manage to produce nearly 7 times more per person in 2008 than in 1908? A little bit at a time. Long-run economic growth is normally a gradual process in which real GDP per capita grows at most a few percent a year. From 1908 to 2008, real GDP per capita in the U.S. increased an average of 1.9% each year. Growth rates are like compounded interest. If the annual interest rate is 10% at the bank, and you are saving $100, after year 1 you will have $110, an increase of 10. After year 2 you would have $121, an additional increase of 11. If the economy grows by 2% one year, and another 2% the following year, and another 2% the year after that, these annual growth rates are compounded into larger and larger increases in per capita real GDP. The rule of 70 approximates how many years it will take for the economy to double at a given rate of economic growth. Here's how the rule of 70 works. It says that the number of years is equal to 70 divided by the annual growth rate. For example, if annual per capita real GDP increases at 5% every year, 70 divided by 5 is 14. So it would take approximately 14 years for the per capita income or per capita real GDP to double. Applying the rule of 70 to the 1.9% average growth rate in the U.S. implies that it should have taken 37 years for real GDP per capita to double. It would have taken 111, 3 times 37, to double 3 times, increasing by a factor of 8. And that is pretty close to what it actually did. This figure shows the average annual growth rate of real GDP per capita for selected countries from 1980 to 2008. Some were notable success stories. However, others have had very disappointing growth, such as Argentina. The million-dollar question then is, why have some nations had faster long-run economic growth than others? Three words: productivity, productivity, productivity. Long-run economic growth depends almost entirely on rising productivity. However, a number of factors affect the growth of productivity. Now, when we use the term productivity, we are specifically referring to labor productivity. How productive is our workforce? A sustained growth in real GDP per capita occurs only when the amount of output produced by the average worker increases steadily. So labor productivity equals real GDP divided by the number of people working in the economy. If workers are creating more output on average, the size of the economic pie will be rising, and the average person slice will also be rising. Why is higher productivity the only source of long-run growth? Can't an economy increase its real GDP per capita by putting more of the population to work? Well, yes, in the short run, like during World War II when women entered the workforce. However, over the long run, the rate of employment growth is never very different from the rate of population growth, so it will not increase real GDP per capita. So then what factors do lead to higher productivity? First, we have physical capital. If you give a worker more physical capital, more tools with which to do the work, he or she will almost always be more productive. A carpenter with a hydraulic nail gun will build more houses in a year than a carpenter with a claw hammer. A bookkeeper with a laptop computer and software will create more financial statements in a year than a bookkeeper with a handheld calculator. Second is human capital. If a worker has more education and training, more human capital, he or she will be more productive. As jobs and the global economy become more complex, nations with a more highly educated workforce will be able to produce more output per worker than nations with a lower level of education. Today, nearly 30% of American workers have a college degree. In 1910, only 10% had college degrees. This has significantly contributed to the growth of the U.S. economy. Finally, we have technology. We can think of technology as our collective body of knowledge. How do we know how to build a satellite that will orbit the Earth and tell me how I can get from my hotel room in Washington, D.C. to the Lincoln Memorial? It takes years and years of collective learning to build such useful devices as GPS systems. These innovations, and many others, large and small, are major factors in allowing an average worker to increase his or her output in a given year. So if you see a worker, or if you give a worker more tools, better tools, and the education and training to know what to do with them, the worker will be more productive and the economy will experience long-run growth. Again, this is going to push that production possibilities curve out to the right, and it's also going to push the long-run aggregate supply curve out to the right, representing this increased productivity.